Hi everyone, good morning. Today we are going to present the beautiful pipeline that we have created for this assignment. So before getting into this pipeline, whatever you see here, let me explain the actual business problem. So here we have taken the telecom industry customer churn data. So basically, the customer churn is a critical challenge in the telecom industry where high competition and evolving customer expectations make retention is a top priority, right? So customer churn occurs when the customer discontinue their subscription or switch to other competitors. This leading to a revenue loss and increasing customer acquisition cost. So the studies indicates that retaining an existing customer is significantly more cost effective than acquiring a new one. To address this issue, we have developed an automated machine learning pipeline that predicts the customer churn using collected data from various sources, including web, transactional records, and third-party APIs. The goal is to process the transform and store the data efficiently while leveraging the feature engineering and predictive modeling techniques to identify the customer at risk of churning. By integrating scalable data pipeline with robust machine learning models, we aim to provide telecom companies with actionable insights to implement targeted retention strategies, reduce churn rates, and improve overall customer satisfaction. So this solution will be designed as a batch processing pipeline, ensuring efficient data ingestion, transformation, and model training at such intervals for the data-driven decision making. So this is a quick intro about the problem statement, what we have chosen. When it comes to the technical solution for predicting the customer churn, uh, we have various stages in the pipeline, as you see in the screen. Uh, Mainly, the various stages focus on data ingestion, scheduling, data processing, and transformation, um, feature engineering and feature storage, model training and versioning, and model deployment. Okay, so here we used various technical stacks to implement the data pipeline. So mainly Apache Airflow orchestrates the schedules, the pipeline, and every 5 minutes. As you see here, the schedule is every 5 minutes this cron will run and trigger the pipeline. Um, and the data is sourced from various locations from like Google Drive uh, in JSON, XML, and CSV formats. And also we have Faker API to generate the synthetic data for training and modeling purposes. And the raw data are placed into this inbound folder, and once it is processed, they will be moved to the processed folder. So here the synthetic data will be moved, and inside we have the CSV and JSON, and here the XML files are being stored. So in this way we are um, maintaining the data for logging purpose and auditing purposes. We are storing the data here, and also we are versioning the data whatever we consume along with the timestamp for auditing purpose. Um, Data, when it comes to data processing and transformation, the Python script we have uh, cleans the data, merge and pre-process the data. And over that, exploratory data analysis is performed to identify the missing values, nulls or outliers, or any inconsistency with the received data. And once the data is transformed, the data will be stored into our PostgresDB. So this is the DB what we have here. We have created this table customer churn new. So here we have this many features, and uh, the whatever the transformed data will be stored into this. And once it is stored, the as I told, the files will be renamed and moved into this processed folder for auditing purposes. And feature engineering is happened on top of the transformed data from the PostgreSQL, and further they are loaded into feature store. This is our feature store. Quickly, I'll show you. So here we have created three different feature stores. One is for custom source and one is a push store, and this is request features. So this request features will be act as on-demand features from the feature store where the calculated value or new features will be computed and stored in the feature store. So for example, here the customer risk adjuster is stored. So this is the calculation that we follow to get the value and store it in the features. I mean in the feature store. And po- and and in Postgres we have these two feast tables created for online and offline data storage. So if you look at this table, we will be having the binary data loaded from the customer churn new table. So the pipeline gets the data and materialize them into these two tables. So here we have around 70,000 records. Uh, yeah, that's the feature store and other stuff. So here and also the feature uh, the feast help us to materialize the data. I mean the versioning the data whenever we push a new data from the various sources. You see here the materialization intervals happened between the times are getting logged here. So every time when we get a new data, this version will be increased and this will be maintained in the feast itself, feature store itself. And we created the feature services, feature store services. Using this service, we will be getting the data to train the models. So if you look at this feature service having the feature view, the customers on new feature view. Inside that, these are all the columns we have. So we will be grabbing the data from using this feature store, and that will be used further for the model training. So for model training, we are using scikit-learn and sklearn libraries to train the models. So here we are using logistic regression and random forest algorithms to predict. And once the data is predicted, the model will be versioned, and the DVC, the data versioning control tool, is used to version the trained models. So this is our DVC repository where the trained models, all the versions will be stored here. So this will be used to deploy the model and do the test. I'll show you all the demo in a minute. So, so mainly here what we developed is like a automated and scalable pipeline. The Apache Airflow ensures the seamless pipeline execution, and the modularity, reusability, everything is well maintained. So wherever we need, all the scripts are independent and we can plug and play wherever we need. Um, and also the synthetic data support we do, the Figure API helps to get additional training data when needed, and this helps to avoid undersampling and data imbalance issues while training the model. And efficient feature management, Feast and Postgres used to centralize and seamless feature storage mechanism. And reproducibility of versioning, DVC tracks the trained models for version control, and also wherever we need, we can we have given the flexibility to the user to select the model when they want to predict the churn. So I will show you in the demo how it is done. Okay, without delaying further, let me start the pipeline and show you the quick demo how it runs and how the data have been ingested, transformed, load into the database, and from there how it is retrieved to feature store, and from there how the model is getting predicted, trained and predicted. Okay, so this is the quick small dashboard in Airflow. If you see here, the this run ran at 8:10 UTC, and next run ran at 8:15, and then this is 8:20, and so that's how the jobs has been scheduled. Now I'll start manually for now to run. So otherwise, let me refresh the page and see when what time it runs again. Okay, so let me start it. This is queued. Yeah, this is just a starting point to start the pipeline gracefully. Um, so now these jobs are scheduled parallelly to consume the data from various sources. The consumer churn data. This is Faker API. Basically, we basically like we have a different two data sources. One is this is kind of a streaming data, so where we will be getting the data as and when we need it, and this is a public data. The download raw XML, CSV, JSON, they are public data we consume from Google Drive location. So the files have been placed over there, and we will be consuming them. So here, if you look at the log, Um, okay, it is still consuming. If you look at the previous one, it consumed with 27 rows. I mean, the 28th file, 27th version received with 138 rows. Okay, so let's see in this version how are we going to get the file. So once the file is received, we can see it in this location. So you see they are all old versions. Once it is processed, they will be moved to the processed folder. So now we got the 28th version. 28th version here in the log also you could see the file have been received with 1048 rows. Okay. Uh, let's take a look at this one. So here also the file has been consumed. The 13th version is in place. Let me check it in the inbound folder. Okay, so yeah, the CSV file has been generated, and the JSON file is in progress. Yeah, it is done. Let me take a look at the pipeline. Yeah, the JSON file is created. You see the 12th version. The 12th version is here. Let's wait for the XML. Yeah, the XML also received. So let's take a look at the pipeline quickly. Uh, okay, the next run also scheduled. So this is manually I triggered. This is the scheduled run. You see here it is scheduled, right? Okay, so let's see. Um, now the transform step runs. Um, let's take a look at the log. Okay. Um, so here the CSV file has been read, JSON, XML files have been read, and along with the synthetic data, and all the files have been merged. Uh, the finally we have 1287 rows merged, and we are storing into them into the table. So this is a quick EDA analysis about the merged data set. So these are all the columns we have, and as part of the EDA what we produced, that data has been inserted into the table. Um, so that there are no log errors in the pipeline in this stage. So we are good. Uh, let's go back to the feast store. It is queued. It's not scheduled yet. Let's wait for some time. In meantime, I'll show you the folders. So here we have the files would have moved into the processed stage. Inside the synthetic data would have moved. You see here it is moved with the timestamp. So mainly the timestamp and version is maintained to partition the data, whatever we consumed, for tracking and auditing purposes. So we are suffixing the timestamp with the files, whatever is being processed. Similarly, in G drive, the data partition is well maintained here in this storage locations. Uh, okay, the 13th version, whatever we consumed, has been renamed and moved. Similarly, for JSON, similarly XML 12th version. So this is what we were seeing in the logs also. Okay, it is still in queued. So in meantime, if you look at this regular scheduled one, we would have received the next version of the file. Let me take you through there. Yeah, you see the 29th file received with the different version. I mean different records, record counts. Okay, now the load feature is done. So load feature store is done. So this is what we have seen. Here, whatever we consumed, those record have been loaded into feature store. Um, so the timestamp also shows the recent time, 9:34. So you see here. Okay. Now the retrieving stage is running and model training also completed. So let's take a look at the logs. And if you look at the feature store here, uh, new source, customer. So here the materialization happened. So the version would have increased in the feature store itself. And so so in this task, retrieve from feature store and train the model. Um, the data have been retrieved from the feature store using this customer v3 feature service, and all the attributes have been fetched from the feature store and applied. Uh, I mean, given input to the logistic regression model and a random forest model. So the calculation and the evaluation metrics have been presented here. As you see here, model accuracy is 81 for logistic regression, and where we got 85 for the random forest. So we feel random forest acts much better on the data to predict the churn. And also the F1 score, precision, recall, support, everything have been printed here. And after this evaluation metrics, we are versioning the models using DVC. So here we are choosing random forest and versioning them into DVC. So you see here the logs where the files have been committed into the repository. Let me go through the logs. So the models also will be placed into uh, our data folder for tracking. If you look at here models, the models, okay, by the time various versions also created. So we are mainly focusing on the 23rd version here. So this churn model and the encoder, whatever we apply on the data, and the scalar values also we are versioning. Those pickles files have been placed into this data models folder, and from there they will be uploaded into DVC. Uh, so here we are doing upload using uh, DVC clients through the pipeline itself. Uh, okay, so here whether the file exists in the folder before committing, we are checking. So the file exists, and here it uh, start committing the file. Okay, the file has been uploaded successfully, and the churn model is getting uploaded. Uh, yeah, here the scalar file is uploaded, and here the model file is uploaded. Here the encoder file. So let's take a look at the DVC repo. So here multiple files have been uploaded. Let me check. Uh, okay, this is 21, this is 23. Yeah, so this is the file what we have uploaded through the pipeline. You see here, churn model is uploaded, and similarly, the encoder pickle file for 23 and the scalar 23 also uploaded. So that's how we versioning the model. And uh, let's see the deployment, how the model deployment works. So this is the deployment step also completed. So I'm going to run the health check. So basically this tells us whether the app is running fine or not. So here we are telling just a message saying the API is running fine. So we have created a test class also where we can pass the input and predict the values. Um, so, and also we have given a flexibility to the user to select the models. So here I'm using the 23rd version. So this is our endpoint, the client endpoint where we can pass the data uh, to predict whether the customer is churn or not. So here also we are comparing the result based on the response what we get from the API. Let me test it quickly. Okay, yeah. So so here we are getting the output also. So here the churn is 1, here the churn is 2. So if you want to change the model also, here we can change the model. So if you want to change, if you want to change the model to lower version also, you can change, and you can test it. Yeah. So that's all. Uh, I just saved the file and running. Yeah. So it is working fine. Yeah, that's all about the pipeline what we have created, and we really enjoyed, and we would like to take a moment to thank uh, the BITS team and our professor who motivated us, and also to my team members who put a huge effort to get it done. So it was a good learning, basically, I would like to say. Definitely, it is a great learning, and we enjoyed, we collaborated well, and we learned a lot of things. We explored so many things, so many alternatives we brought into the table, and we did our best. And we hope we presented well on the component whatever we developed. Thank you, thank you, thank you again.